Okay, back from the short break, we continue in the program. More key content from the INAC study will be presented, but we have changed the order of the talks because Professor Stephen Thomas is not there at the moment. So the next speaker is the last one of the morning, Nikolaus Müllner. He is a physicist and has worked for many years at the San Piero Agrado Nuclear Research Group at the Pisa University of Technology on nuclear safety issues. Since 2013, he is working as senior researcher at the Institute of Safety and Risk Sciences at Buku University in Vienna. And meanwhile, he is deputy director of the institute, and he is the chairman of the International Nuclear Risk Assessment Group, INRAG. And he will talk about double standards between existing and new nuclear power plants. And I announced already that after the 3 or 2 talks in the late morning, he will thankfully serve as our facilitator, since I have to join another international meeting for a little while, so that you know that already. But please, Nikolaus, it's your turn.
Thank you, Wolfgang. Hello. I'm going to talk about double standards between existing and future, existing and new nuclear power plants with a question mark. I'm just trying to switch the slides. So I would like to ask the organizers to give me the possibility to switch the slides. The link that I received is not working. Okay, so you switch the slides. Okay. Okay. So the European nuclear power plants, in average, the average European nuclear power plant has more than 36 years of operation. Most of the European nuclear power plants received their operating licenses in the 1970s and 1980s. But in the meantime, we had 3 major nuclear accidents going on. 3 Mile Island, Chernobyl, Fukushima. There were many smaller accidents and incidents. There were other events, like, for example, 9/11. So there were a lot of events which had an influence on nuclear safety and on the state of the art and of nuclear safety, and also on the requirements of nuclear power plants. Next slide, please. Okay, now it's working. So, I mean, this was touched a little bit also by previous speakers. If a nuclear power plant wants to operate, oops, sorry. Oh, I see them with a little bit of time delay. Okay, now it's okay. So, okay, so safe to operate. What does it need? What's needed for a nuclear power plant to get an operating license? Basically, they have to demonstrate that they are safe. But safe in an absolute sense, in a sense that nothing ever can happen under no circumstance, is something which you cannot show for a nuclear power plant, obviously. So there are, if you have a reactor core which is generating a lot of energy, and you have all your fission products just in this core, then some event always can happen and destroy your barriers, and it can come to a release of those radioactive materials. So safety in an absolute sense is not possible to show. And what you show instead is the nuclear operator presents a safety case where he analyzes a spectrum of possible initiating events and basically looks on the consequences of those events and shows that the consequences are below acceptable limits. And those limits are somehow is somehow what given by society. So in the it is something which is negotiated between regulatory authority, operators, politics. So you set your limits. You limit your consequences such that if the consequences are below those consequences, yet you accept them. And there is something else what you accept, since you cannot investigate every initiating event, every pipe break, everything that at the nuclear power plant. So this means you have also to accept that the events that you not investigated, that they may have consequences which are way above the threshold that you choose as consequence for this as acceptable consequence for the society. And those events and those falls under residual accepted risk. And so this means what an operator basically shows is that the residual risks are sufficiently small. They are not zero, but they are sufficiently small, and that the consequences are limited. So how was this in the 1970s when a nuclear power plant was licensed? Basically, you were looking at a few limiting cases, like for example large break, loss of coolant accidents. You were looking on the largest pipeline of the nuclear power plant, looking what would happen if this would break. You were looking, evaluating what could be the design, the maximum earthquake that happens at your site, 1 in 1,000 or 1 in 10,000 years, depending on the plant and on the country. You would look at what kind of weather conditions you have to expect, and then you would show that for all those events, if they happen, the engineered safety features of your nuclear power plant are able to limit the consequences to the accepted region. Okay, but as I mentioned in the introduction, since then we had 3 Mile Island, Chernobyl, 9/11 attack, Fukushima accident. So what is now if you want to get a license for a nuclear power plant now, you have a lot of additional things to look at and to analyze. So you for example you look at small breaks. One of the consequences of the TMI accident was that not only large breaks could have consequences, but also small breaks, and that large break accidents are not always covering your small break accidents. You would, from the Chernobyl accident, you would look at reactivity coefficients on the void coefficient, power coefficient. From the Fukushima accident, now you look at severe accidents. Plants, if you now construct a new nuclear power plant, this new plant has to show that it somehow has the possibility to mitigate a core melt. from that time, what was also recognized, that there could be common cause failures. So if you build all your safety trains exactly the same way and one fails, you have a very high probability that also the second and the third will fail. So now if you build your safety trains, you have to build them all, each one different from the other. So to avoid a common cause failure, you have to separate them physically, so that if one is failing, that you have a chance that the other safety trains are surviving. We have now a different aircraft, which we consider as basis for design against aircraft crashes. In the 1970s, 80s, you had small military aircrafts. Now, if you build a new plant, you have to consider a commercial airliner, and so on. So this means we made a lot of experiences in the last 30 years, and all of those had an influence on safety research. And this means if you are now building a new power plant, a new nuclear power plant, you have to consider more events, and you have to look at more things than a nuclear power plant was looking in the 70s. So if you build a new power plant, let's say the situation is easy, you have still your accepted consequences and not accepted consequence, and you simply have to show that for all those additional situations, the consequences will stay in the accepted domain. But what to do with the existing power plants? And so let's look a little bit on the international guidance for existing power power plants. So IEA specific safety requirements, design. How should you design your plant? And if you look this design now covers basically all the things I mentioned. Now the design requirements. So to what plants does this document apply? And if you read in the introduction, application of safety standards, IEA safety standards are applicable as relevant throughout the entire lifetime of all facilities and activity, existing and new, utilized for peaceful purposes and to protective actions to reduce existing radiation risks. Which is rightful so, because if you license a plant or not cannot be, if a plant gets its license, cannot be subject if it's old or new. So, but should be the rationale behind it should be are the consequences below what a society wants to accept, or are the consequences, may the consequences be above? So there must not be double standards when it comes to nuclear safety. However, since there is no really agreement on this, there is in the same section, a few paragraphs later, there is something which is limiting this first sentence, and here the IEA SSR 2-1 recognizes that existing plants may not fulfill may not fully met the standards, the current standards, and how to apply the IEA standards to the existing plants. This is up to a decision for the individual states, simply because there is no consensus among the member states on this issue. And how is this in the you see this theme that we have a difference between new and existing plants also in several other documents. For example, the Convention on Nuclear Safety issued the Vienna Declaration on Nuclear Safety after Fukushima accident. And here, basically, it was recognized that nuclear power plants should avoid early and large releases. But I mean, this statement is not something very new, to be honest. Yeah. Also in the 70s, it was required from a nuclear power plant that it would not have large releases or very early large releases of radioactive materials. Simply the difference is that in the 1970s, many of the threats which could lead to early and large releases were not known. So this is not, let's say, if you look on the standards that you require from your nuclear power plant, this is not something new to require. However, nonetheless, existing installations should adhere to these standards only as far as it's reasonably practicable to implement safety improvements to bring the old plants to this so-called new standard, which is in reality not really a new standard. So what is the situation in Europe? And in Europe, we have one document on the Nuclear Safety Directive was from 2009, which was updated in 2014. Also, Gerrit Niehaus cited it already. Here also, you have the one technical requirement in Article 8, that nuclear power plants should not have early radioactive releases or large radioactive releases. And existing nuclear power plants should see this as a reference and should try to adhere to it as far as possible, basically. So again, you have in many documents, you have double standards codified, double safety standards. So what is now, if you apply this, what is the situation? If you look at an existing nuclear power plants, so for the original events, the consequences are in the accepted region. For all the threats and risks that were discovered following following the taking into operation of these nuclear power plants, we don't know if the consequences are in the accepted region, and they may not be in the accepted region. And also the standards that you require for your new nuclear power plants, for example, on your redundancy of safety systems to deal with common cause failures. This is something which is very difficult to retrofit in existing plants. And so what is the actual situation? We adhere to the safety directive. So this means we try to identify where can we make safety improvements. As you see these arrows which reduce the risk. Yeah? So you certainly, if you do some retrofitting, you reduce the risk of existing plants, but you don't apply strictly the criteria that you would apply for new nuclear power plants. So this means you apply the criteria for its licensing base from the 1970s, and for all additional risks that were discovered afterwards, there is the obligation to try to identify reasonable improvements, and that's it. Yeah, so you don't have a guarantee that you are within the new standards with the old plants. Yeah, you don't have to show this, and you are not. Yeah, you are not with the existing plants at the same level as you would be for new plants. And you, what Wolfgang Renneberg was also saying, you don't even have to show where you are exceeding the limits that are set for new plants. Yeah, so you don't know how much am I different from what I would require for a new plant. And how to do it differently? Yeah, not all countries are using this approach. If you look at Japan, Japan shut down all its nuclear power plants after the Fukushima accident. The safety authority laid down state-of-the-art standards. And if you want to operate your nuclear power plant in Japan now, you have to reapply for a license, and you have to ask for a reassessment of the existing plant according to new standards. And the operators decided to roughly to ask such a license for half of the fleet. And half of the fleet in Japan was shut down since it would not pass the test according to new standards. This is something which we did not do in Europe. So to say as a conclusion, there are double standards on nuclear safety in Europe. The new nuclear power plants have to adhere to the state of the art of nuclear safety. The existing plants may not only deviate from the state of the art, they don't even have to show how much they deviate from what we require from new nuclear power plants. So this means we are accepting from the existing plants a risk that we would not accept from a new nuclear power plant. And also in Europe, as you will see from Stephen Thomas' presentation, the large part of nuclear generating capacity comes from lifetime extension, and there are basically no new builds in Europe planned. So with this, I want to close. Give back to Wolfgang.